decoding for fixed length codes which we have encoded. This table I have taken from the previous slides where we have assigned 3-bit binary codes to individual characters of the file. Character E has been assigned 3 bits, again A to N has been assigned 3 bits each, binary codes. Suppose we have this binary formatted message which we need to transfer from source to destination, or which we want to decode from one in one machine. So for example, this is the binary message, and in fixed length coding, we already know that each character is representing with 3-bit binary codes. So we can group this entire binary format, binary message, into threes. First 3 bits, second 3 bits, third 3 bits, and last 3 bits, starting from left to right, reaching till the right end of the message. We have grouped the entire message into threes, and now we can decode it by looking at the coding table. 010 is has been assigned to character C, so we can decode it like C. 001 has been assigned to character A, so we can decode it like A. Like this we can decode the entire message using fixed length coding. Now we have earlier seen that fixed length encoding requires larger space than variable length encoding. But variable length encoding is quite difficult to decode the message. It's not quite easy as it was easier in fixed length decoding. This is the variable length encoding table which we have calculated in the previous example. E has been assigned the binary code 0. Such a way we have got this binary message 010010 for decoding. And what does it mean actually? Because we do not have in hand the technique like clubbing, grouping the binary bits into 3 as we were doing in fixed length decoding. We do not have any technique to decode it because it's a variable length encoding. The bits are varying. Here 1 bit assigned to character E, 2 bits are assigned to character A, 5 bits are assigned to character K and N. So it's a variable length encoding. We cannot group this input binary message into a specific bit pattern. 3 bits, 2 bits, 1 bits, we cannot group it. So it can mean anything, any message, because we can conclude that 0 is assigned to E, so we can say that the first character is nothing but E. 01, so the first character could be A. So it means anything. We cannot properly decode the message. We cannot tell if the original message is this or this or this. So can you guys identify what the problem here is? Here the problem is the code word which is assigned to character E is prefixed to the code word assigned to character A. Similarly, the code word which is assigned to character A is prefixed to the code word assigned to character C. So problem here is one code word is a prefix of another code word. So to decode the message in variable length decoding, we need to tackle this problem of prefixes or prefix codes. So we need to make the code word prefix free. To tackle with this problem, we generally want that each code word which we are assigning to each character is not a prefix of another code word. Such an encoding schema is called as prefix codes or prefix free codes. For a text encoded by a prefix code, we can easily decode it in the following way, such as suppose we have got this binary formatted input message which we want to decode. Start with first step, that is scanning from left to right to extract the first code. As soon as you get the first binary code, complete binary code, extract that letter. Again repeat the scanning. Again repeat the scanning till we reach to the last bit of the message. First we'll scan for the first binary code, second we scan for the second binary code. That binary code will be of any length because it's a variable length technique. So basically prefix code or prefix free codes are nothing but assigning each character such a code word which should not be the prefix of another code word. Hope you're understanding this prefix codes. Here how we can assign the prefix free codes to each character of the file. In the previous variable length encoding, here you can notice the problem or the bug. Here we were assigned 0 to code word, to assign the code word to character A. Here 0 is the prefix for this code word, 01 is the prefix for this code word. Here we have tackle this problem by utilizing different code word for assigning the character A, different code word for assigning character C. Here you need to make sure that no code word is prefix of another code word. That is the only funda behind this, by for assigning the prefix free codes to the characters. And in variable length decoding, we have this problem of prefixes. This is the input message which we want to decode by using prefix free codes. These two steps we need to perform: scan from left to right to extract the first code. 0, look for the coding table, look into the coding table whether 0 is present in the prefix code table or not. 0 is present, just decode that code with character E. Then again repeat the same process. 1 is not present in the prefix free code table. 1010 is present, so decode it like A. Next 0, yes it is present, so decode it like this. 0 is present. 1 is not present, 10 is present, so the decoded character will be A. This is the message which we will get at the receiving side after decoding it. This is the original encoded message with the help of prefix free codes encoding technique, where we have make sure that no code word is the prefix of another code word. That is the only funda behind prefix free codes while encoding. And while decoding, we need to perform these two steps. First step is to scan the binary message which we want to decode from left to right. Extract the first binary code, that is, look into the coding table, 0 is present. Extract the letter which is assigned to that binary code, and that is your decoded message. Hope you understand this concept.